Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, our topic is mechanical modification problem solving. In this, various kinds of techniques are involved in this mechanical modification. So, according to each kind of techniques, what are the detailed solutions, what are the step-by-step procedure is involved. So, what kind of improvement is required, modification is required for that particular soil. So we will understand in our previous theory classes. Now in this problem solving and practical applications where we are applying using some numerical examples. So here the first one is the blasting. So in this blasting, so according to we consider some example. So when we are going to construct highway construction, the project is highway construction. The project is highway construction. The project is highway construction. Soil type is loose granular soil. Soil type is loose granular soil. This is the type of the soil. So this is the project which we are going to construct. This is the soil type. So the depth of the loose soil is the 5 meters. So blasting, we are the technique which we used for getting the desired properties for construction the highway in that particular locality. So we are using the explosive material that is equal to ammonium nitrate fuel oil. ANFO, that is ammonium nitrate fuel oil. So the charge placement is every 2 meters in grid pattern. And the charge weight is 5 kg per charge. And blast sequence, sequential detonation with 0.5 seconds decrease. So these are the numerical example we have. So already we decided. So as per the knowledge, as per the understanding the site condition, we are going to decide what kind of material we are choosing, where it is going to place, how much weight is required for that. These are the parameters already we know in our as per the technique. So now how we are doing this process. So here first we are going to assess the site assessment. So in this site assessment, determine the depth of loose soil is equal to 5 meters. So assessing the properties and also using the SPT, standard penetration test, we are understanding what are the soil properties involved in that particular locality. Now design blast pattern. So here determine grid spacing is 2 meters. Already it is also consider every 2 meters we are consider in grid spacing. Calculate the number of charges required for this particular area. Now number of charges is depends upon the area. So that is equal to 25 charges after getting the calculation. It may vary. So this is the procedure how we are going to do. So here the 10 into 10 divided by 2 square, because it's a square grid. So every spacing it is there. So that's why, otherwise 10 by 2 square. So we will get the 25 charges. See here blasting. In blasting technique, what we are adopted for blasting technique for getting the soil desired properties of the soil for construction of the whatever the thing here, that is highway. So here the safety measures is very important. So the safety measures is very important in any kind of soil modification based on the technique. So here blasting has the high in any kind, in all the techniques, the safety measures are very important. In this we are established a safety radius typically 200 meters. It depends upon the which type of explosive we are choose. So according to that, how much safety radius is required and which type of construction, where it is located, heavy rocks are there, loose soil is there. It depends upon the type of the soil and what kind of explosive we are using, on spacing, how much area we are covering these blasting. These are all the parameters to establish this safety radius. So implement these safety protocols to protect workers and structures. So the blasting execution place 5 kg of ANOF at each of the 25 grid patterns. Detonate charges sequentially with 0.5 second delays to ensure controlled compaction. So in this post-blasting assessment, for in blasting process, we have to understand the assessment. So here conduct standard penetration test post-blasting to confirm the soil density and compare SPT values before and after. So then only we will understand we will reach our goal or not. So we will reach our expected outcome or not. It is depends upon the post-blasting assessment. So conduct standard penetration test post-blasting to confirm soil density. Compare SPT values before and after. So pre-blasting SPT values 10 blows per foot. Post-blasting SPT value is 30 blows per foot. So like that we are conducting the test. We are understanding the what are the various steps involved in this particular blasting technique. Now we are going to one more kind of technique, that is vibro compaction in mechanical modification. Now in mechanical modification, one of the technique we are going to choose for getting the desired properties of the soil. Here also port construction on reclaimed land. So here the project is port construction. The soil type is loose sand. The compaction depth is 10 meters. The vibration frequency what we consider that is 30 Hz. Insertion interval every 1.5 meters. So the compaction duration is 3 minutes per insertion point. These are all the known things because of this numerical example. Otherwise we are going to choose. So we are going to do the construction that is port construction and it is loose sand. So for this, what are the things we are required for this? We are what kind of the here what we require, that is the compaction we are doing. It is depends upon the according to that we choose this vibro compaction. Then we'll know how much compaction depth, vibration frequency, insertion intervals. So now in this the detailed solution and calculations, site assessment. Identify the depth of the loose sand that is 10 meters. Assess soil properties using cone penetration test. So for understanding the properties involved in this particular locality, we choose this cone penetration test. Now equipment setup. Position the vibro fluid at 1.5 meter intervals in a 10 meter grid pattern. Calculate the number of points. Those number of points we are going to find out, that is using this technique, using this formula, that is 49 points. Here the compaction process lower the vibro fluid to 10 meters. Active vibrations at 30 Hz. So this is the compaction process which we follow for this vibro compaction for getting the required desired compaction properties for getting the construction. So now gradual withdrawal. So we are going to withdraw these vibro float slowly while vibrating for 3 minutes per point. For 3 minutes per point we are going to reduce this. We are going to withdraw these vibro fluid slowly. Ensure even compaction by maintaining consistent vibration. We are going to maintain the even compaction. Maintaining consistent vibration, then only we will get these even compaction. That maintenance is also important for getting the desired property. So here for quality control, perform cone penetration test for before and after the technique is used. So you before using this technique, applied this technique, what is the CPT value, and after what is the CPT value, for understanding about the what are the changes happened in the soil properties using the technique. Now dynamic tamping. So in dynamic tamping we choose warehouse construction. This soil type is loose file. Weight is 20 tons. Drop height is 15 meters. Drop points every 3 meters. Number of drops per point is 10 drops. We are designing, we are understanding as per the requirement of the warehouse. The type of soil is loose soil. We require the compaction of the area. So for that we choose this dynamic tamping technique. Now these are the numerical values we are there. What are the things we will do using these? How we are applying? What is the detailed solution and their calculation? So here the project is warehouse. Soil type is loose fill. Here determine the depth of the loose fill 5 meters. Assess soil properties using plate load test. We are assessing the soil properties using the lab test. We are finding the soil properties using the plate load test. And now weight and drop, we use 20 ton weight drop from 15 meters. So from the 20 ton weight we are dropping the 15 meters. Now the grid pattern, what we understand, that is equal to 20 into 20 grid pattern with 3 meter intervals. Now we are calculating the how many number of points is required. So that is 49 points. Now this how we are executing this compaction? We are drop the weight 10 times at each point. So every point where we decided in those 49, the drop of the weight from 15 meters height with 20 tons weight, we are dropping same kind of the drop for every 10 times at each. Now calculate the impact energy. So that is equal to weight into height. It depends upon now. Impact energy is equal to weight multiplied by height. That is equal to 20 tons multiplied by 15 meters. That is equal to 300 ton per meter. Now that is the impact energy which we create. Now verify, conduct plate load test post compaction. So the post compaction bearing capacity is 50 kilonewton per meter. Pre-compaction of post compaction bearing capacity is 150 kilonewton per meter square. For understanding the how much tamping technique we used after the compaction. So these are the things we are going to follow for this dynamic tamping. Now compaction piles. In this compaction piles, we choose the residential development. Type of soil is loose clayey soil. Precast concrete piles we choose. Those pile types, also different types, it is choose according to the requirement. Here we choose the precast concrete piles. Pile length is 12 meters. Pile diameter is 0.4 meter. Pile spacing every 2.5 meters in grid pattern. So here the detailed solution that was involved is, first we assess the site assessment, determine the depth of the loose clayey soil, that is 12 meters, and assess the soil properties using the soil boring and testing, and pile driving. So this it depends. So this is the common primary step which we conduct for any kind of mechanical modification and any kind of modification technique. We are going to understand the site assessment. The next step, it is depends upon the which type of technique we choose. Here according to that, drive 12 meter long 0.4 meter diameter piles at 2.5 meters intervals in 20 to 20 grid pattern. Calculate the number of piles which are required. We are monitoring the pile driving to avoid excessive vibrations and ensure proper depth. So these post driving tests, perform load test on 5% of the piles to confirm soil density. So compare soil density before and after. So pre-driving soil density, post-driving soil density, we are going to find out using the test. So here using these compaction piles, it depends upon it is a technique we choose for project requirement and the type of the soil. So here we are doing what kind of property modification, that is density. So like this we are going to understand what are the various parameters which are going to involve in the particular technique. So in compaction piles, so what type of project requirement it is, what kind of soil we are choosing, here the parameters. So after doing the calculation, finally post driving test we are conducting for understanding the soil density, the property, whether it is modified or not, how much it is modified. These are the parameters which we are going to understand. So in this, the blasting involves the use of controlled explosives to create vibrations that compact the soil. It is primarily used in granular soils where shock waves cause the soil particles to rearrange into the denser configuration. So in a highway construction project, the future roadbed is loose and contains more voids. Controlled blast is employed to compact the soil. A series of small and strategically placed charges are detoned, causing the soil particles settles into the denser state. These results in stable and firm foundation for the road construction. And in this detailed solution, what we understand, determine the soil type, depth of the loose soil layers. So the design blast pattern is going to calculate the amount of explosive material and design the placement of charges. These safety measures implement safety protocols to protect workers and nearby structures. This blasting execution also detonate the charges, including control sequence to achieve the desired compaction. So post-blasting assessment, conduct test to ensure the soil has reached the required density. In vibro compaction involves the use of vibrating probe that is inserted into the ground. The vibrations cause the soil particles to rearrange and compact, increasing the density of granular soil. In the construction of port, the reclaimed land consists of loose sand, a vibro probe which is used to compact the sand. The probe is inserted to the ground and vibrated while being gradually withdrawn. This process densifies the sand, providing a stable foundation for the port structures. In detail, we done this site assessment, identify what are the soil properties and target compaction depth, equipment setup, position the vibroflate at the designed location, compaction process, lower the vibroflate into the ground and active the vibrations, gradual withdrawal, slowly withdraw the vibrofloat while continuing the vibrate, ensuring the even compaction, quality control, perform density test to confirm the effectiveness of the compaction. These are the steps involved in this vibro compaction. In dynamic tamping, also known as the dynamic compaction, involves dropping a heavy weight from high onto the ground surface. The impact energy compacts the soil, making it denser and more stable. In preparing a site for large warehouse, the underlying soil is loose and contains numerous voids. A dynamic compaction rig is used to drop 20-ton weight from 15 meters a regular interval across the site. The repeated impacts compact the soil, ensuring a stable foundation for the warehouse. Here also, the detailed solution is site assessment to determine the characteristics and depth of the loose soil, weight and drop, select an appropriate weight and drop height based on the soil properties, grid pattern, plan a grid pattern for the drop location, compaction execution, drop the weight at each point in the grid, moving systematically across the site. These compaction piles, description, compaction piles involves driving piles into the ground to densify the loose soils. The displacement of soil by the piles increase the density and strength of the surrounding soil. Example, in a residential development project, the soil is too loose to support the plant structures. Compaction piles are driven into the ground at regular intervals. Their displacement caused by the piles compact the soil, creating a stable base for the foundation of the houses. In this site assessment, analyze soil conditions and determine pile specifications. Pile driven the piles into the ground using a pile driver. Spacing ensure proper spacing between the piles to achieve uniform compaction. Monitor the driving process to avoid excessive vibration that could damage nearby structures. Post-driving testing. Perform load test on the piles to ensure design compaction and bearing capacity. These are the various techniques which we are used for this mechanical modification. For understanding the various kinds of techniques involved, how the site assessment and the properties are involved in that, for getting the desired properties as per the project requirement. These are the some of the technique we choose in our mechanical modification as per the project requirement. And various properties, those are densifying, compaction and density we are getting. So these are all the things we are going to do in these mechanical modification techniques. In these techniques, we are going to understand what are the various parameters. Finally, it depends upon the what type of project we are constructing. Where it means in soil property, soil type, which soil type we are doing this thing. So these are all the parameters we are understanding for choosing the technique. Once we choose the technique, again in the so many design parameters are involved. So it depends upon the technique. Blasting, it has its own kind of properties, steps involved in for getting the desired property. Vibro compaction, it has their own kind of steps involved for getting the desired property, and also the dynamic tamping. So the huge amount is going to drop down for getting the compaction. So nearby surroundings are also we have to understand in that particular parameter. Blasting as well as where we are blasting, which kind of explosive we are choose. These are all the various parameters which are involved in these mechanical modification techniques for choosing for the according to the type of the soil. So these are the some of the numerical example we observe in this class. Few more are there. Few different kinds of problems and practical issues we are understanding what are there for solutions in these mechanical modification techniques. So we will see in our next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.